In this video, we're going to talk about pH. So pH is a measure of how acidic or how basic a solution is. A pH equal to 7 means that the solution is neutral. There's the same concentration of hydrogen ions as there are hydroxide ions. When the pH is less than 7, it means that the solution is acidic. There are more hydrogen ions than there are hydroxide ions. And if the pH is greater than 7, it means the solution is basic, and there are more hydroxide ions than there are hydrogen ions. And this is shown on this continuum of the pH from 0 up to 14, where the solution is acidic, and then it becomes less and less acidic until it becomes neutral, and then it starts to become more and more basic up into a pH of 14. But what exactly does that number mean? So it's actually a representation of the concentration of hydrogen ions in the solution. So when we talk about the concentration of hydrogen ions, if we're talking about a concentrated strong acid, they can be as high as 10 moles per liter. But if we have a concentrated strong base, the concentration of hydrogen ions can be as little as 1 times 10 to the negative 15. So that is a really big range in concentrations. So that wide range plus those negative powers of 10 are not really very convenient to work with. So that's where the pH scale comes in. So pH is a logarithmic scale. So pH is the negative log of the hydrogen ion concentration. So if you have the hydrogen ion concentration, and that's what those square brackets mean, concentration of hydrogen ions, and you want that concentration to be in moles per liter, so you can substitute that into the equation and get the pH. And you can also go in the other direction. You can calculate the concentration of hydrogen ions if you have the pH, because it's 10 to the power, to the exponent of the negative pH. So if we look at some examples, the concentration of hydrogen ions in pure water has been determined to be 1.0 times 10 to the negative 7 moles per liter. So what is the pH? pH equals negative log of the hydrogen ion concentration. So negative log of 1.0 times 10 to the negative 7 moles per liter. And so if you're not familiar with logarithms, it's really, you can just think of it as it's a button on your calculator. So when you take the log of 1.0 times 10 to the negative 7, you get an answer of negative 7. And then negative of that gives you a positive 7, right? Which makes sense. We were expecting a neutral pH because we were talking about pure water. When you're doing these calculations, there is another significant rule, significant figure rule that you have to keep in mind. So when you're using logs and exponents, it's a special case. So another rule to learn. So your pH value needs to have the same number of decimal places as the number of significant figures in the concentration. So when we look at the concentration here, 1.0 times 10 to the negative 7, the 1.0 has 2 significant figures. So our pH has to have 2 decimal places. So that's why I've written it as 7.00. So here's another example. The concentration of hydrogen ions in a solution of phosphoric acid is 2.3 times 10 to the negative 4 moles per liter. What is the pH? So you use the equation, you take the negative log of that 2.3 times 10 to the negative 4. And when you put that into the calculator, you end up with an answer of 3.64. And again, because the concentration has 2 significant figures, our pH has to have 2 decimal places. So now we can do calculations in the other direction. A solution of sulfuric acid has a pH of 2.75. What is the concentration of hydrogen ions? So we use the equation that the concentration is equal to 10 to the exponent negative pH. So that's 10 to the exponent of negative 2.75. And so you ask your calculator to figure that out for you. And it turns out that it's 0.0017783 moles per liter. Now, we have to think about the significant figures. So you need to use the opposite of the rule that I just mentioned. So your concentration needs to have the same number of significant figures as the number of decimal places in the pH. Right, so the pH 2.75 had 2 decimal places. So your concentration is going to have 2 significant figures. So that's why it's written as 1.8 times 10 to the negative 3. You wouldn't have to put that into scientific notation. You could have left it as 0.0018 moles per liter. So those are the calculations that you will need to be able to do with pH. So either given the hydrogen ion concentration, calculate the pH, or given the pH, calculate the hydrogen ion concentration.